Okay, let's unpack this. We're doing a deep dive today into this really interesting stack of sources you sent over.
Yeah, they all center around this paper from Apple Machine Learning Research, came out February 2025, The Illusion of Thinking.
Right, the illusion of thinking. And it took a pretty critical look at the big, large reasoning models, OpenAI stuff, Claude, DeepSeek, Gemini, all of them.
And it definitely made waves. Some headlines were like, Apple topples the LLM industry, which is a bit much.
Yeah, a bit dramatic.
Right.
Because a lot of experts in the field were saying, well, the core findings aren't entirely new.
Exactly. So our job today, using your sources, is to cut through that, understand what the paper really found, and look critically at its claims and what they might mean for you.
Okay, so the central argument, the big idea in the illusion of thinking, seems to be that even though these models look impressive on some tests,
Their actual fundamental reasoning ability, we don't really get it. That's the core claim.
they're saying the standard tests we use are flawed, partly because the models might have just seen the answers, or things very like them, in their training data.
Right. That's the contamination worry. So to get a clearer picture, the Apple researchers proposed using these controllable puzzle environments.
Like little digital sandboxes, things like Tower of Hanoi, checker jumping.
River crossing, blocks world, yeah. The idea was these let them carefully control the complexity and sort of watch how the LRMs try to think through the problem.
Okay, and the findings. This is where your sources say it got really interesting.
Yeah, quite surprising. First off, they found these top-tier LRMs don't just get a bit worse on harder problems, they hit a wall, a complete accuracy collapse.
A collapse, not just like more errors.
No, a sharp failure point. Beyond a certain complexity threshold, performance just plummets. For Tower of Hanoi, one source mentioned they basically fall apart after 7 or 8 disks.
Wow, 7 or 8, that seems low for models this powerful.
It does. And maybe even weirder is what they found about reasoning effort. You know, how many tokens they use.
Right, you'd expect more tokens for harder problems, more thinking.
That's what you'd think. But the paper says they found the opposite. As tasks got difficult, the models started using fewer tokens, thinking less, not more, even when they could have generated more.
So,
Yeah.
they just give up or freeze. That's counterintuitive.
It really is. And they also struggled with things needing exact calculation and couldn't really use algorithms properly, even when the steps were given to them.
Okay, so clear limitations highlighted, but your sources also pushed back a bit, right? Raised some critiques.
Definitely. One big one was, well, if you're worried about test contamination, why pick super famous puzzles like Tower of Hanoi?
Yeah, good point. Those are almost certainly in the training data somewhere, aren't they?
Probably. So it creates this known puzzle paradox. Is the failure a lack of real reasoning, or just the model failing to reliably pull up a pattern it already kind of knows? It muddies the water a bit.
So is it failing at logic or just bad at remembering the specific trick for that puzzle?
Exactly. And there's also debate about whether token count really shows productive thinking. Fewer tokens could just mean the model's confused or breaking down, not being efficient.
Right, and the big question, do failures on these abstract, symbolic puzzles tell us much about reasoning on messy, real-world problems? Do they generalize?
That's key. But what's significant, even if the ideas weren't totally new for insiders, people like Gary Marcus have been raising similar points for a while.
About pattern matching versus real understanding.
Precisely. The Apple paper provides clear empirical data using these specific puzzle environments. It gives that critique some concrete experimental backing.
So it adds weight to the argument that just making models bigger might not be the whole answer for getting robust reasoning.
Yeah, it suggests we need maybe smarter, not just bigger designs, perhaps hybrid approaches, combining neural nets with more traditional symbolic AI.
And it also pushes for better ways to evaluate these things, doesn't it? Looking at the process, not just the final answer.
Definitely. Understanding how they arrive at an answer or why they fail.
Okay, so wrapping this up, what's the takeaway for you listening? This Apple paper gives some pretty compelling evidence that the thinking we see in LRMs might be more like an illusion.
An illusion born from incredibly sophisticated pattern matching, rather than the kind of deep, flexible reasoning we associate with human thought.
It really challenges us to think about what we mean by thinking or understanding in AI.
These models are powerful tools, no doubt, but seeing them fail so sharply on these fundamental logic and planning tasks, well, it raises a crucial question for you.
If they can stumble executing clear steps in a controlled puzzle, How much confidence should you place in their reasoning when things get ambiguous, complex, and, frankly, real-world important?
So something to definitely think about.